Now, this is a bunch of basically using graphs and looking at the functions of sine and tan and cos, and then using the graphs to find answers to questions. So it says, given that sine of 60 is root 3 over 2, use a graph to find all values of theta in the given interval for which sine theta equals minus root 3 over 2, and show you're working on the graph clearly. So if you're going to do this, what you need to do is look at these, and then you're going to draw your graph. Now the first graph you're going to draw, usually, is actually how sine works. So it's always between 1 and minus 1. That's 0. And this isn't in radians, it's in, what's the word? It's in degrees. So sine of 0 is that, 90 minus 90. So that goes up and there. And this goes down and there. It's not perfect, but it'll do. Now we know sine of theta equals minus root 3 over 2. Where's that gone? Can't see it. Anyway, I was going to use another colour, but I'm not now. So root 3 over 2 is going to be at 60, so that would be there. So that would be there. Those would be the two answers to this one. But this one means that it's going to be minus 60. And if it's minus 60, then by the rules of, what's the word? So let's say that's minus 60. Then by the rules of symmetry, that means it's 30 down to minus 90, and then it's another 30 down to 120. So the answers to sine of theta equals minus root 3 over 2, without using a calculator, are that theta equals minus 60 and minus 120 using the graph. Now, the answer to why it's not above 0 is that it will start going down after 180, but right now it's not going to. So you won't get an answer. You'd probably get 180 plus 60, which is 240, but that's not within our limits. So we don't need to worry about that. Now, so that's our sine. Now sketch the graph of y equals tan theta minus 45 in the interval. Now this is 360, minus 360 to plus 360, so this will be interesting. So I'm going to do this. I really need another colour for this to work, but let's see what happens. So this doesn't do minus 1 to 1, but we have, if you remember, 90, this could be interesting. Looks like that. That's our asymptote. And this is minus 90, also an asymptote. It would help if I did a slightly better jagged line, and so that goes like that. Okay. Then this will go at 180. So we'll go through, and then there'll be another asymptote at 270. And then at 360, you'll go through again. Okay, so that's that. And then minus 90, so let's go to minus 180. And let's go through that. And then at 270, minus 270, you've got another asymptote. And then at 360, it comes down from there and goes like that. So that should, that's what it looks like. Now at tan minus 45, now please, so, there it is. Everything is fine, I can use another colour, so I'll use green. So theta minus 45 means that it's in the brackets. So we're now going to add on to where it would normally go through. So now we're going to make the middle point. So it would be minus 90, it would go to minus 45. And now, and that means our asymptotes are going to go down by 45, hang on. So it goes up by 45. So that means our asymptote goes there. And our thing goes through 45 here. So imagine that that goes that way. Now imagine that means that's 90 on that side. So that means that R1 goes through that. And then it would be an asymptote at 135. There you go. So that's what it looks like now. And then it would go through, if that's 45, then it would go through 225. And that's 270. So it would go through about there. I don't love the way I've drawn this. And then would go down there and go up to there. Okay. On the same set of axes, draw, oh my God, for the interval, oh no, in the interval that. So find all the values of theta for which tan of equals that. So when does tan normally equal 1? So what is the, if we put in tan 1, what does that give us? Sorry, let's do shift tan 1 equals, so 45. So normally tan 45 would equal 1, but now when does it equal 1? It equals 1 at 90, and then it equals 1 at, good Lord, 270. So it would be 45 minus that. So 270 is going to be the next one. And then we take 180 from 90 and we get minus 90. And then we take 180 from minus 90 and we get minus 270. So that's what you get if you do that. I apologise, I just had to look at that and read off it, not perfectly. Now on the same set of axes, sketch the curves of y equals half sine x and y equals sine of theta minus 60. So I'm going to be a little bit careful. So let's just do this. And normally our answer would be 1 and minus 1. But we know in this case it's a half for the first one and minus a half. And I'm going to use black for this, and I'm going to go, it's between 180 and, there we go, so that's 90, 180, 0, 90, 180, and those are minus, obviously. So we're going to go, that's what, if you've got a half in front of it, you halve it. So it literally goes like that, and it goes down to minus half and along to that. So that what we've done is shrunk it. If we had a 2 in front of it, we would grow it to 2. Now, the sine of theta minus 60. So that means normally, I'm going to put that one in, we would go through 0 at 0. But now we're going to go up 60. So that's the answer. And that means that when it's 1, it would normally be 90, but it's going to be 1 is going to be at 60, 90 plus 60, which is 150, which is there-ish. So that's when it would be 1. And so that goes like that. And then I'll start going down again. And let's just think about what that also means for this. So that means minus, so the point where it would be 0 again would be 30 along. So 60 along there, so it'd be minus 30 there, and that is 60. So it would then go down to minus 1 at, so it's 60, so it would go down to minus 1 there, and then it would go up to, hoping I can get away with this, so then it would go along like that. Right, now, any points where the curves meet the coordinate axis, so it meets the coordinate axes at 60, so on the x, it would meet the coordinate axes at 0, 60, and then, but that doesn't meet there because it goes beyond 180, and then it would meet again at every 180, so go down to 120, so 0, 120. So that's one of the points for the second one. This one meets it, so the black one meets it at 0 minus 180. Good Lord, this is the other way around. So it's 0, 60, 0, 0, 60, 0, 120, 0, and minus 180, 0, and 180, 0. Is where they meet that. And then the black one meets the y-axis at 0, 0. And this one meets the axis at when that equals that. That would be going through. Now, minimum points. Show algebraically. So maximum and minimum points would be, this one here would be, we think, so it'd normally be 90, so that's 120, 150, 1. And then this one would be, that would normally be minus 90, so that's minus 30, minus 1. Okay, so I've done that, and then the maximum point of that is going to be 90.5, and the maximum point of this is going to be, the minimum point is going to be minus 90 minus 1/2. Okay, show algebraically that theta satisfies all of these things, so half sine theta equals sine theta minus 60, and that means that sine theta equals 2 sine theta minus 60, and then that would equal, and I think those are the only things which actually suit it. So we know that it crosses at half at 90.5, and we know, and that's because if we put in sine theta equals, so if we put in 2, then sine 90 minus 60, that equals 30, which sine 30 is half, so sine theta equals 2 sine of 30, and 2 sine of 30 equals 1. So sine of theta equals 1. There we go. Oh, which is also when 90 equals that.